I thought I'd just continue the waving because I was watching myself wave for like 5 minutes straight. Welcome, everybody. This is episode 2 in our Learn Live series focusing on building intelligent apps with AKS. Today, it's a pretty cool topic, I would say. We'll cover how you can actually run open source models on AKS. And the key thing here is how you can actually reduce your time to inference using Kaito, which is the Kubernetes AI Toolchain Operator. So this is going to be a fun one. For those of you that don't know me, my name is Paul Yu. I am a cloud native developer advocate here at Microsoft. I'll be your host today, and I am very excited to introduce to you my special guest, Ishan Segal. Yay!
Thank you, Paul. Yeah,
Ishan. Yeah. Just tell us who you are, introduce yourself, and tell everybody what you do at Microsoft.
Yeah. So hi, my name's Ishan. I'm a software engineer on Kaito in AKS, Azure Kubernetes Service. Yeah, and I'm just passionate about AI infrastructure to run AI workloads. Yeah.
Yeah. Ishan is my ML expert here, so I'll be leaning on him not only in this, but forever. Now that I know what you do here at Microsoft, so I'll be bugging you.
Glad to have it.
Okay. Next up, let's see. I do want to give a quick shout out to our moderator for this session, Stephen Morawski. He's a teammate of mine on the Cloud Native Advocacy team, and he will be behind the scenes on the keyboard answering all of your questions in the chat. So please drop a note in whatever channel or platform you're in and say hi to Steve. Hey, Steve. I know we're streaming on Twitch and a couple different YouTube channels. So the Microsoft Reactor YouTube channel and also the AKS Community YouTube channel. So yeah, wherever you are, drop a note, say hello. So here's what we're going to be doing today. Again, these sessions are actually meant for you to get hands-on with the technology. So if you browse over to this URL here, or bring out your phone and snap that QR code, you'll be taken straight to the workshop instructions, and this is what we'll be working through. Again, it's live interactive, so drop a note. Okay, as far as learning objectives for today, as I mentioned, this is episode 2. And so we're going to be deploying the same exact application that we deployed last week in episode 1. If you haven't done that yet, no worries. We're going to start from scratch. But if you're curious about the application and how we went about deploying it, I suggest that you go back to either of the YouTube channels and you'll find the recording over there. Okay. But today, what we're going to do is we're going to first deploy the intelligent app to AKS, and then we'll deploy Kaito in our AKS cluster. Now, I'm going to deviate just a little bit from my normal demo flow. I like to talk about the thing and then go do the thing. But because some of this stuff takes a little bit of time to provision, more specifically like the GPU nodes taking time, I'm just going to jump right into our demo app and deploy the app, deploy Kaito, and then we'll dig deeper into what Kaito is. And then once we've done all that, we'll see how easy it is to actually swap out our GPT-3.5 Turbo model with the open source Falcon 7B model. Okay. So when it comes to deploying the store app, if you've been in our previous streams, you've probably seen this a lot. And so I'll just reiterate it real quick for you. This is what we'll be doing. As I mentioned, deploy the AKS cluster, deploy the demo app with OpenAI, deploy Kaito, okay? And so what this demo app will do is we're mimicking a couple different scenarios, business cases, right? So this demo app is actually meant to serve as a fictitious e-commerce application. It actually serves 2 different purposes. One is the front end, where customers can actually browse the website, look through the product catalog, add the items to the cart, and check out. And then we also have back end functionality, where users will be able to, where employees will be able to take a look at the order, process the order, and more importantly, manage the product catalog. Okay. And so we initially didn't have AI in this application. And so we wanted to make this app more intelligent. And we wanted to leverage a generative AI to help us with things that are hard, like creating a description for products. And so what we'll do is we'll leverage generative AI to give us a product description based on a product name and keywords. And so that's the whole premise of this application. Just to walk you through really quick around the application architecture, just to give you some more visual on what this is. So customers will come in to the storefront. They'll be able to browse the product catalog, which is, this is all built on microservices architecture, by the way. And so the storefront will be able to call the product service, retrieve the product catalog, display it to the user. The user will be able to check out, and that order gets submitted to an order service. And then eventually it floats over to RabbitMQ. For the back end, employees will log into their own web portal, but it calls the same product microservice. And here, because we want them to be able to process orders as well, we have a secondary microservice in here, which will be able to retrieve orders off of the order queue and then store that order into a more persistent database. In this case, it's MongoDB. Now, these are all containers running in our cluster, and more specifically, so are the RabbitMQ and MongoDB. They're running as containers, and we just did that just for ease of use, and so that you can actually deploy it into your own, even your own local Kubernetes cluster. So if you're running Kubernetes in Docker Desktop, Rancher, Minikube, Kind, whatever, you can actually deploy this entire solution in a local desktop. You don't even need the cloud for this. But there's you can easily swap out RabbitMQ with Azure Service Bus or Azure Cosmos DB if you wanted to. So, but the whole point of today's workshop is to add intelligent capabilities in how we can do that on AKS, right? And so we will deploy this AI service, which is written in Python. It uses the semantic kernel SDK, which we use to kind of interact with various large language models. Initially, we'll start off with AI service talking to the Azure OpenAI's ChatGPT 3.5 Turbo model. But the whole point of today's workshop is to actually deploy an open source model on our cluster, right? And so we'll actually be replacing the GPT 3.5 Turbo model with Falcon 7B. So let's just jump right into the demo and do that. Hopefully you scan that QR code and you're taken to this workshop material here. I'm just going to go through just some of the steps here, get the cluster up and going. And so there's a couple things that you need to be aware of if you want to run all this locally. You need to have all these tools in place because we're using Azure Developer CLI to provision everything. If you don't know what Azure Developer CLI is, go back to episode 1. We covered that pretty much in pretty good detail. So you'll need all of these tools, right? And it's a lot of stuff for you to go and download and install. And so it's much easier if you just launched a GitHub Codespace, because the GitHub Codespace is basically your development environment in the cloud. It's all container-based. And what we did is we actually pre-installed all the tools for you, so you don't have to go and do all those installations yourself. Okay, so what we'll do is we'll actually jump out to the AKS store demo repo. And what you want to do here is click this code button here. And then when this panel opens up, just make sure you're clicking that code spaces button. I already have a code space. But if you didn't have one, you'll see a button in the middle. It says create code space. So go ahead and click that button. So let me go ahead and actually, I won't click this because I already have it open. So I have my code space here. and that code space will actually clone the repo and give me a working environment. So if I do AZ account show, you can see that I'm already logged in. Yep. So that's where I want to be. So let's go back here. Open the repo and code space. You should be in good shape. Now let's go ahead and get this demo application up and running. Okay. You need to do an AZ login. You need to do 2 logins, unfortunately, because it's using Terraform in the background. So you need to log into number 1, the Azure Developer CLI, and you need to log into the Azure CLI. So do these 2 different logins. And then what I'll do is I'll create a new AZD environment. So that's not what I wanted. There we go. So I'll create a new AZD environment because this is AZD can manage different environments for you, like deployments, like dev, test, whatever. And so it's going to ask me for a new environment name. So I'll call it Kaito. And the next thing I want to do is I need to set some environment variables because I want to deploy the intelligent capabilities into the solution. And so let me just go ahead and grab those. So if I go here, I want to deploy OpenAI. So I'm going to set this value to true. And then I want to deploy Azure Workload Identity. This is very important because we're going to need workload identity enabled on our AKS cluster in order for the Kaito operator to work successfully. So we'll go ahead and copy this, paste that in, and I need that.
Yeah, that workload identity is important because we're provisioning GPUs on your behalf. So
right. Yeah. Okay. Now, if I do get environment variables, this is what you should see. So environment name is Kaito. OpenAI is true for now, and then workload identity is true. And so all you need to do is do a AZD up. It's going to ask me for what my where I want to deploy into what subscription, and the region. The region is important, okay, because we're deploying a ton of different services here. Some services may not be available in every single region. So just to play it safe, I would pick either East US 2 or East US because I know all the services that I need are there. So go ahead and do that, and it'll actually do the deployment. So AZD is a pretty cool way to get up to speed on your deployment. It actually will provision the infrastructure and deploy the actual application as well using a Helm install command. So it's pretty cool. I don't know how much AZD you've done in the past, Ishan.
No, I hadn't heard of it actually before you mentioned it. That's super cool. I think you mentioned it uses a variant of maybe Terraform as well.
Yeah, it can actually. It's basically like it's a CLI wrapper for other infrastructure as code and basically any other CLI tool. So one CLI, and I'm actually invoking. AZD is invoking the Terraform apply command in the background. Yeah, so that's why you see all these are Terraform things. So this is like Terraform deployment information if you're familiar with that. But yeah, it's just for me, I like it because it's convenient. So
yeah, you can get like a reliable. You can use your favorite infrastructure as a code, right?
Mm-hmm. Yeah, you can do Bicep or Terraform. Yeah. Okay, so I think we'll let this cook for a little bit, and let's jump back into slides while we're waiting on this. This should take about 5 minutes. So while we are waiting,
and I think Paul, you mentioned this, right? But to make sure you have enough quota. I somewhere in there you said that.
Yeah. I'll show you how to do that. And quota and regions, that's where it's super important, right? Because you get assigned quota per region, per Azure region, I should say. So yeah, it's super, super important. Okay, so while that's cooking in the background, let's talk a little bit about AI workloads on AKS. Okay.
Yeah.
So when it comes to AKS and what makes it a great platform is that AKS, I mean, we've up until this point, we've only been using, in terms of like intelligent app capabilities, we've only been using inferencing endpoints. And these inferencing endpoints, especially with OpenAI, um, either OpenAI, the public API, or Azure OpenAI, it's just a REST endpoint, right? That lives outside of the cluster. But AKS has a little bit more to offer than that, right? So as part of like the entire Azure ecosystem, you can actually go beyond the basics of just calling inferencing endpoints and do more things like model training, fine tuning,
Yeah.
and have all that within the confinements of Azure walls, so to speak, right? So yeah, I mean, Azure gives you that platform, and it enables you to have like end-to-end integrations, especially when it comes with data ingestion, governance, identity, just all built into the platform, which is really neat, right? Ishan, I don't know
Yeah.
like what your experience has been with like model training and fine tuning, but I mean, what do you
Well,
think?
I was gonna add like first that I mean AKS is managed Kubernetes, so it's
Right.
managing the infrastructure for you. It's managing that node that is running Kubernetes. So that I mean that's taking that complexity out. And then just like you were saying, it has that integration with the Azure ecosystem. So Azure Files, blob storage, all the other stuff that you want to use. And I
Mm-hmm.
think you touched on this as well. Like it has the security features. So yeah,
Yeah.
AKS is providing it's letting you manage. It's managing your Kubernetes for you. Um,
Right.
yeah, and then I'll just briefly say like why like it's also important to use Kubernetes for AI workloads. People might ask, why use K8s? But my answer to that is another question, which is like, if you're not going to use K8s, like, what are you going to do? Because if a VM or a service goes down, like your inference
Mm-hmm.
endpoint, then you have to attach another node. You have to get it set up on that other node. But with Kubernetes, you evict the pod and it gets reassigned to another VM. So yeah, that's just the resiliency aspect, the scalability aspect, the data management. Kubernetes is just
Yeah.
it's great for running AI workloads for those reasons. Yeah.
Yeah. And it's like the core principles of Kubernetes, right? Scheduling and
Yeah.
scaling all through infrastructure abstractions, right? It just makes it super easy from like an operator perspective, um, to just declare these as like manifest files and hand it over to the cluster. And then, off it goes and does its work, right?
Yeah. And,
Um,
and you're dealing with containers, so you also don't have the it works on my machine problem, right? Where
yes. Yeah.
you know, um, yeah.
Yeah.
So for all of those reasons.
Exactly. So you have containers, and you're able to fit a lot more, or actually like do a lot better bin packing, right? In terms of like
Mhm.
squeezing the most juice out of your infrastructure, right?
Yeah.
And that's all things that Kubernetes can kind of do for you on your behalf, right? So it's pretty cool. And I didn't even put these on the bullet points, but like, you know, you're able to scale your container workloads, and then
Yeah.
with Azure and the cluster autoscaler, you're actually able to scale out your cluster as well, right? So grow the cluster as needed, so based on your workload. And then the other cool thing that that's here is the second bullet point: Azure support for GPU and InfiniBand, right? So that's going to be super important as you get into more of the I don't want to call it the earlier stages of the AI, but I guess it is like model training, fine tuning,
Yeah.
having your workloads communicate with each other, like having multi-instance GPUs, and having all that communicate over InfiniBand. I think that's super important, right? Because
Yeah.
InfiniBand gives you that super high performance, super low latency network
Yep.
communication between nodes,
Between
which is
GPUs.
like
Yeah.
really important, right?
Yeah.
When it
Yeah.
comes to these large training jobs. So
Yeah, that is super important because there is a lot of overhead. If you didn't have InfiniBand, there'd be a lot of communication overhead between between nodes. So
Yeah.
yeah, InfiniBand and accelerated networking is another thing that are
Yep.
both in Azure, so supported by the
Cool.
SKUs. Yeah.
Cool. Let's check on the app. See how it's doing. Boom, 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 boom. Let me switch over here. Hey, look at that. It's 5 minutes. Did I predict 5 minutes? Or did I say a few minutes?
Yeah.
Whatever it is. We're pretty good. Let's see. So I should do a kget PO. I think it's in the pets namespace. There we go. So we're up and running. A couple of restarts here, but that's okay. That's what Kubernetes does. If your pod goes down, it'll reschedule it, right?
Yeah.
Okay, cool. So let's jump back over to the instructions and see where we are at. So I did the AZD up. Okay, so what I'm going to do is I'm going to just grab some of the environment variables and just kind of load them up, because the Terraform, I actually wrote the Terraform to kind of like spit out a bunch of like outputs. And so what we'll need is we'll need some of these outputs to actually configure Kaito. So what I'm going to do is just clear that. I'll just go ahead and load that up so they're all available to me. And if I go and test the application, grab that IP, we shall see it working. HTTP, boom, A. Okay, let me increase the font there. So this is the back end, excuse me. And what we'll do is we'll take a look at the products. We can see we have a list of products, and I will add a new product, and I'll add the same product that I added last week. I know Steve has a cute new dog in his family, and the dog's name is Bear. So I'm going to name it Bear's Snacks. Okay. Let's call it Treat. Okay. So what I'm going to do is I don't want to write that product description myself. I'm going to go ahead and ask the AI assistant for that. So there we go. Reward your pup with the Bear's Snack. Okay. So I like that. So there we go. So we have a new product in our application, and we can start selling this new product, right? So if I were to go back to my instructions, we have our demo app running, and it's actually has intelligent capabilities now, but it's talking to Azure OpenAI. The next thing we want to do is we want to see if we can swap it out with an open source large language model and have that all running within AKS. And so if I head over to the next page here, don't worry about this for right now. We're actually going to go ahead and walk you through the deployment, and then we'll talk about what is Kaito. Okay. So let me just scroll down here, probably to the next page. This is where quota is important. Okay. Because we are now going to run our large language model inside of the AKS cluster. That requires GPU-based virtual machines. Not everybody has access to the VM SKU that you're going to need. The VM SKU that you're going to need here is coming from this particular family, which is a standard NCS v3. I don't know off the top of my head what sort of GPU that's running. Maybe you do, Ishan, but you need to make sure you have enough quota for that. Okay. So what I'll do is, let's clear this. Here's a handy Azure CLI command that you can use to check your quota. Okay. So I'm just doing a AZVM list usage based on the location that my cluster is in. And you can see that from this family of SKUs, I don't have any provision right now, but I have a quota of 12 available. And you're going to need exactly 12 to do the exercise. So if the difference between current and limit is less than 12, unfortunately, you won't have enough quota to actually deploy the virtual machine and add it to your cluster. So if that's the case, what you're going to need to do is in the Azure portal, you're going to have to request a quota increase. And that's pretty simple. You can actually just in the Azure portal, just come right over here to the support section. And you can just literally type in VM quota. And this wizard will kind of walk you through. It'll walk you through the process in submitting that quota request. So, and I've seen it. I've seen the quota request go pretty quick. So
Yeah.
I think a lot of times now there are automated. So, but let's go ahead and do the deployment.
I also see there's a question in the audience here.
Mm-hmm.
Yeah. So somebody was asking about which is a better option for ML workloads, AKS or Kubeflow. Does Azure have managed Kubeflow like Vertex AI pipelines?
Yeah, just to quickly answer that question, we do have documentation for installing Kubeflow into your AKS cluster.
Right.
So, oh man,
put me on the spot. They're two different things is what I was going to say. Yeah, like you're getting at, Paul. Right.
Yeah. So this here. So if you go to this here, and let me just drop it into the chat window so that it can be shared out. But this is documentation that was updated.
Yeah.
Think about within the year for sure. And it'll walk you through how to deploy Kubeflow onto your AKS cluster. But yeah, as you were saying, Ishan, you said there were two different.
Yeah, I was just really going to say like AKS is managed Kubernetes is the offering, because I think he's asking which do you use for ML workloads. AKS is managed Kubernetes. Kubeflow is that open source project for deploying the ML workloads. So you
onto
can run
Kubernetes, right?
Yeah, exactly. Right. So you can run Kubeflow on AKS.
Right. On any Kubernetes cluster. Yeah, really. Yeah. So
yeah.
Okay, let's move forward with the Kaito installation. And again, we'll talk about what Kaito is, but there's an important thing that Ishan mentioned. Kaito is basically going to provision the GPU nodes and add them to your cluster on your behalf. And so in order for Kaito to do that, it needs to have an identity to work with so that it can actually go do that on your behalf in your subscription. And so we're going to do that by creating an Azure managed identity and creating a federated credential. And we've had a few sessions on workload identity in AKS, but essentially we're going to be leveraging the OIDC issuer that's inside of the Kubernetes cluster, along with the service account, which is also just another Kubernetes construct. And we'll be federating this identity to an identity that's in Azure that Azure AD, or excuse me, Microsoft Entra ID will know about. Okay, so we'll need to create this identity, okay, and then give it this role assignment. So it's going to need to be at least a contributor for your cluster. And then we'll actually do the federation here, okay? And the important thing to note is the subject, right? In addition to the issuer. But the subject is super important because when Kubernetes pod goes out and says, hey Azure AD, or hey Microsoft Entra, can I get a authentication token? What Azure AD is going to look at is the subject of that request. And that subject is basically saying, I'm coming in as a service account in this GPU provisioner namespace by this name. Okay, so that's super important. So we need to go ahead and execute all these commands. And I'm not going to copy every single command one by one. I actually have it on a clipboard over here. So, oops. Let's go ahead and paste that. So these are my commands, right? We'll create the identity, create the role assignment, and then federate those credentials. We'll just give this a second, and okay, we should be good there. Next thing we're going to do is we're actually going to install the Kaito operator, and we can actually do that using Helm charts. Ishan and the team, they did something pretty cool. They actually publishing all these to a Helm repo that's hosted in the actual repo of Kaito. So we can actually go run this command, Helm repo add. So Helm repo add. Kaito already exists because I already added it. And then what we're going to do is this. The Kaito operator has two controllers. Okay. And I know I'm getting into what is Kaito, but I just want to just call this out because I want you to know what this is doing here, like why we're creating this file. So GPU provisioner is actually going to do that, provision the GPU for you. And so it's going to need a lot of your Azure information, right? Yeah. So it's going to need to know what your subscription ID is, the cluster name, the node resource group name, and then the client ID and the tenant ID, right? Because that's how it's going to know how to work within your Azure subscription. So we're going to need that file, and we'll actually use that file when we install the Helm chart. Okay, so if I do this, close that. So I'm going to install the Helm chart, and I'm going to pass in that GPU provisioner values file. Okay, so the GPU provisioner is deployed, and then we'll need to install this Helm chart for the workspace. Okay. Okay. So now, once you have a workspace, once you install the Helm chart for the workspace, what you're going to get is you're actually going to get custom resources, right? So if I did a kubectl, and I've actually aliased my kubectl to K because I'm lazy and I only want to type K. I don't want to type kubectl. So if I do kubectl API resources, let's do it without the grep. So if you do API resources, you can see all the things that are available for you to actually deploy into your Kubernetes cluster. But if I did actually let me do that. So if I did API resources and I just do pipe it to grep Kaito, you can see that I have this custom resource, which now I can start using. And if I did a kexplain workspace, then it starts to kind of tell me how I can start building this manifest, right? And so what I'll do, just for the sake of time here, because this does take a few minutes to deploy, is I'm going to actually deploy a workspace, and we'll actually go into what all this is in a second. But essentially what we're doing here is deploying the Falcon 7B instruct workspace by using this preset, and Ishan will be able to talk you through what a preset is. And we're going to deploy using that SKU. Remember, we did the check for the SKU, and I did say that having 12 cores is super important because we are specifically using this 12 vCore SKU here. So what I'll do is I'll go ahead and deploy that.
Yeah, so just to reiterate what you're saying, that workspace is the user-facing API.
Mm-hmm.
It encapsulates all the requirements you need for running your inference model, that's our goal, to make it as simple as that. I could even talk, Paul. There's 3 types of workspaces you can make.
Okay. While this is cooking, let's flip over to the slides and let's talk through it.
Yeah, sure.
Let's get back here. Okay, what is Kaito? So let's just skip over these slides a little bit, and we'll talk about what Kaito is, and then I'll jump over to. Actually, I'm going to jump around in the slides if that's okay.
Yeah.
Okay, so let's look at the high-level architecture. What do we have going on here?
Right. Yeah. So It all starts with the workspace. So that's what you just created there. So
Mm-hmm.
that's that like I was just saying that's that user facing API that encapsulates all the requirements that you need for running the inference model. The workspace also goes ahead and it creates a CRD for the node provisioner. So it creates a node provisioner object.
Mm-hmm.
So that was that GPU provisioner that we were talking about. That's going to go. The node provisioner creates it's called a machine CR,
Mm-hmm.
and that interacts with the AKS agent pool API for provisioning your GPU node, which you're going to need for your workload, for the AI workload that you have there. So yeah, so workspace is creating that node for you as well, because it's
Mm-hmm.
creating that node provisioner CRD, and it's also
So
then
as a user, all I need to do is just
yep,
deploy my workspace into the Kubernetes cluster,
yep,
and then that will actually create this additional CR over here.
exactly, yeah.
Cool.
So we want to make it as simple as you just create the workspace. That's all you have to worry about.
Mm-hmm.
And you give it so you gave it Falcon 7B instruct. So
Mm-hmm.
now workspace is also going ahead and pulling an image down, which is the Falcon 7B instruct image with the model weights in the image, um, and all the relevant dependencies that you need to run, Falcon 7B instruct. So it's doing a lot
Right.
of good stuff. And no provisioner is also making sure that the NVIDIA driver is on the machine, and it's making sure that the container toolkit is on there, and the device plugin, NVIDIA device plugin, is also running. So it's doing quite a couple things to make sure that everything's running. It, yeah. And Torch, of
Right.
course, that's the other thing I was just about to say. It makes sure that the AI workload also makes sure that Torch is downloaded, PyTorch, to run your model. So we don't want people to have to worry about like what version is compatible with this, what driver should I use, what Torch version should I use. Like
Right.
those are problems that people shouldn't have to worry about. So right, so that's why
Right.
we want to take care of that for people.
Right. So basically, GPU provisioner is in here, but you don't interact it with it directly.
Yeah,
Um, you're actually interacting with the workspace,
yeah,
and this will actually enable you to create that GPU node, configure the inferencing endpoint, which is a whole different animal, right? Like you have the model, but just having the model, I mean, you need to have some sort of like application that can actually talk to the model, right? So that's what you're setting up as well.
exactly. Yeah, you're gonna need. Well, you need to run that model at some endpoint. You need to have all the dependencies, like we're saying. You need the model weights. Yeah. So
Right. So then it invokes the GPU provisioner, and the GPU provisioner, it's interesting. It's using Carpenter APIs for
yeah,
machine.
yeah. So it's using Carpenter APIs, and that's how it provisions the
Yeah.
virtual machine. Yeah.
And for the folks on the call, if you're not aware of Carpenter, so Carpenter is an open source project.
Yeah.
I believe it originated out of AWS, and they donated it into the CNCF, the Cloud Native Computing Foundation. So Carpenter is a pretty neat way for you to further abstract the way machines or nodes are provisioned in the cloud, based on whatever manifests, like based on certain VM profiles that you ask for or request. And so within the machine config that the workspace will create for you on your behalf, it kind of lays out all the different, I guess, VM SKU permutations, and it'll actually go ahead and provision that machine for you. So it's pretty cool that the Carpenter APIs are actually in use over here. In Azure, I think we have kind of like almost like a managed Carpenter. If you haven't heard it, it's called node auto provisioning. So will that come into play eventually?
Yeah, that's like the goal. That's what we're investigating right now. Yeah, putting in uh,
Yeah. But I mean, either way, I think it's good to use, because for machine configuration, I think Carpenter is becoming a pretty big thing. And
Yeah.
so, yeah, it's pretty cool. And if you're curious, we can actually look at it. You'll actually see the CR in the cluster because the
Right.
workspace created it for you on your behalf. Cool. So just going back a little bit in my slides here. So let's talk a little bit about we know what we know what Kaito is now, and we have a general idea of how it works, right?
Yeah.
So just to reiterate, you install these things into your cluster, and they're essentially controllers in your cluster that listen for certain activities. So as soon as you, the user, submits a CR, a custom resource for the workspace, off it goes to do its thing, right?
Yeah.
And so it's going to actually provision the GPU nodes, pull the models down, and deploy the inferencing endpoint. So it's doing a lot of work behind the scenes, and that's why it takes a little bit of time to do it. Why? You're thinking probably now, okay, great, this is cool. I can provision the GPU node and deploy my model, but like, what is Kaito really solving for me, right? Why would I need this? And these are some of the things that Ishan kind of talked through. And you've probably done this a lot in your previous life, right?
Yeah.
and come across some of these things. But these are things that, a lot of application developers, like I'm not a ML engineer, but I don't have a ton of experience there. So a lot of these things that I don't really understand, but there are definitely challenges in setting this stuff up, right? So
Yeah.
long wait times to load, right? So like, what are your, like, out of this long bullet list, like what sticks out to you the most, Ishan?
Yeah, I mean, there's a couple different things. I remember, so I used to be so I was an ML engineer, and of course, it's just like the different versions, mismatches. It's a huge just annoyance. The other thing is, there's also like setting up the environment, so installing the necessary, dependencies and plugins. And then, of course, you have to containerize everything too. So you have to write a Docker file, and then
there's a very specific way in doing that, right? Like you have to make sure. I think it's here. Like make sure that you're tuning the deployment parameters to fit the GPU, right?
That's another one.
Specific CUDA versions that you need for specific models, isn't that right?
Yeah, like you have to make sure that the CUDA version is compatible with the NVIDIA driver that you're using, as well as the PyTorch version. So there's things like that.
Right.
Yeah, and then it's nice we have the model weights in the container image, and that's what's nice, because if the pod goes down and it restarts, the image is still there on the node, so it'll be able to restart quicker than having to pull down the weights every time into that pod. So you don't have to do that that wait time. It's like a much better like UX, customer experience. They go, the model, just, everything is there and it just gets set up. Yeah, so all these little things, and I think there might even be a slide too on like what it looked like before and what it looked after, right? It's
let me pull that up.
Yeah,
it's the goal is, and Kaito, its initial iteration of Kaito, from what I understand, is the focus is purely on inferencing for now, right, Sean? And so the goal, the initial goal right now, is to reduce your time to inference, and reducing that, especially if you need to have a model hosted in your Kubernetes cluster. There could be various reasons why you would want to do that. It could be centered around data security, data sovereignty, data privacy. maybe you don't want to call out to an external service for your inferencing. And maybe you need that in the cluster, right? So it's all about pulling that model in and getting your inference endpoint up. And so the things that Ishan was talking about, of like before, this is what you had to do, right? You had to set up the environment, set up the model, containerize it, right? And so, and of course, deploy it, because building that container is one thing. Hosting it is, hosting the container is another thing, but also deploying it, right? So you got to set up all these Kubernetes resources, like your deployment, if you're using a deployment, or if you're using a replica set or a stateful set, right? So
you got to make sure you have obviously enough hard disk space so that can store your model. That's one thing, and then you have to make sure you have enough GPU memory, of course, right, to run. In this era of like LLMs, I mean, like we just deployed Falcon 7B, that's 7 billion parameters. So, you got to make sure that you have at least, like, in this case, I believe like 16 gigs of GPU memory. So
it's 7 billion. That's considered their small model, right?
Yeah. So you're seeing some interesting things happening with models right now where smaller models are coming about, like Phi-2, right, which are highly trained models for a specific task. And then at the same time, you have really massive models coming on, right, like with larger context windows and general purpose models. So you have these interesting like Moore's law effects going on here, where more and more models are coming out, and eventually things are going to get more efficient and model costs will go further and further down. And then it becomes an infrastructure problem, and it becomes more about what's the resources running underneath. So anyway, just a lot of cool developments going on with these LLMs, right?
Yeah, no, it's all super cool. So I mean, like, this is the goal of Kaito right now, is we're going from this long list of tasks that you need to make sure that you take care of to deploy it into your AKS cluster, to reducing it all the way down, right? To literally, we did it, within a matter of minutes. We installed the Kaito operator using the Helm charts that's available to us, and then we deployed a workspace custom resource. Now, we did use presets, and I think we should talk a little bit about presets, Ishan, but before we do that, let's go check on the deployment. Let's see. Boom. No. There we go. Okay. Hey, look at that.
Awesome.
In 11 minutes. That's pretty good, actually.
Nice.
I've seen it take longer. Looks like the demo gods are with me today.
Yeah, we've made it quicker. Yeah.
Yeah. Whatever you did behind the scenes, Ishan, thank you.
It's working. Yeah.
Yeah. Okay. So a couple things to look at here, because there's a lot of things that it's doing in the background that we saw, right? So number one is the resource ready, meaning the machine, right? And then number two is the inference ready, right? Because we'll take a look at it in a second, but you do get your own inferencing endpoint. And then number three is making sure that the workspace is just in general is ready, right? So you want to make sure that all these are on the up and up, true, and then you're ready to rock and roll with this thing. So let's bail out of that, and let's go explore a couple things. If you're curious to see what the GPU provisioner is doing, you can actually go take a look at the logs of that specific pod. And so you can see that launch the machine, right? And so it used this machine configuration. So if I do that, kget machine,
right?
I can't remember. There we go. It's like what workspace or what namespace. It's not namespace. So, YAML. So look at that. So the workspace actually did all this for you. It created a new Kubernetes resource of machine type, and it just configured all this and deployed all this for you. And then the the GPU provisioner, the controller actually submitted this to Azure and was able to provision this particular virtual machine. So you can see the SKU in here as well. So that's pretty cool. We can actually test the endpoint out, right?
Yep.
So what I'll do is, let's take a look at the services. Okay, get SVC. I can't remember what namespace they go into. Okay, so it's going to be that right here. Okay, so what I'll do is I'll actually run a curl pod in the cluster, and I will ask it a question. The question I'm going to ask it is, what is Kubernetes? So let's see what happens. Drum roll, please.
Drum roll.
So let's see here. So what's going to do is actually going to create a brand new curl pod, execute the curl command, and then immediately exit. So that's why you see the curl.
So we're using the cluster IP. Yeah, that's why we have to make sure we have a pod that's in the cluster to hit that.
That's correct. Yeah, because there's an option, right? We have options.
There's an option to use an external load balancer IP too, and that would allow you to do it from anywhere. Yeah, so that's one of the annotations in the beginning. There was an annotation you set. You could set that to true.
Yeah. I'll point that out in 1 second. But let's take a look at the answer. So Kubernetes is an open source container orchestration platform developed by Google. It is used to deploy, run, and scale containerized applications. Wow, yeah, that's pretty good.
There we go.
Pretty good. Yeah, there we go. So it's actually it's working, and it's working pretty well. Give me a nice, clear, and succinct answer on what Kubernetes is. So I'm pretty happy with that. I think I'm ready to deploy this into my actual overall solution and swap out and basically pull out OpenAI and replace it with Falcon. So let me go ahead and do that, and then we'll talk a little bit about what that workspace manifests, what it really comprised of. So what I'm going to do here is I'm actually going to rely on AZD again, but this time, in the beginning, we actually set this deploy OpenAI to true, but now we're going to set it to false. Basically, it's going to delete that deployment for me. So if I jump over to Azure, and I can't remember what the name of that resource group is. I use funny little pet names for my deployments. Moved grub. That's an interesting name. So you can see I have Azure OpenAI deployed over there. I don't want that right now. I want to get that out of my resource deployment, because now I'm running it in cluster. So there's no need for me to pay for OpenAI if I don't need it. So we'll go ahead and let that do its thing. That should take like a minute or so. But let's take a quick look at that, that resource definition. So if I do this, boom, 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 boom. And if I scroll down, sorry for all the scrolling, folks. But here is the manifest that we deployed, right? This is how you can toggle on or off, whether or not you want your inferencing endpoint to be externally accessible or not. So I set this to false. And when you set this to false, that service that we're querying, you get a cluster IP. So meaning it's only accessible from inside of the cluster. If you set this to true, it's going to change that service type to load balancer, and then you'll get a public IP, and then you'll be able to call your inferencing endpoint from outside the cluster. So the thing that I love about the CR is super simple. Not a whole lot of stuff that you need to configure, right? So you just need an instance type and then count, right? So what does count give us here, Ishan?
Yeah, count gives you the number of nodes there for that model. So so for Falcon in this case, if you specify like 2, or 3, it'll run Falcon on both nodes. So and then when you do a request, it'll load balance between those two.
Yeah. Now just to clarify here, will I get a second GPU node, or is this going to give me a second deployment? like a pod
Yeah, that's a
essentially.
good question. It'll give you a second GPU node. So it'll get
Cool.
the count there specifies how many nodes you're going to get.
Mhm.
And then we take care of running Falcon across those nodes. So we take care of everything
Right.
else there. Yeah.
Right. So the
Yeah.
so the cool thing here is now we're getting into the realm of like distributed inference,
Yeah.
right?
Yeah.
Where we can distribute the load across many GPUs. And so I know here we're using a 12 vCore uh,
Mhm.
machine that has, I don't even know the number of GPUs it has off the top of my head, but what that distributed inferencing enables you to do is basically rather than using big, huge virtual machines with a ton of GPUs on it,
Yeah.
you can now spread that across maybe lower end VM SKUs, but
Mhm.
multiple versions of them, right?
Yeah.
So,
Yeah. It also comes into play like what the model you're running is, what the preset you're using is, because there's different model architectures.
mhm,
So the other example is Llama. So for
mhm,
Llama, uh, the model weights are sharded, so little
mhm.
pieces of the model are running on different nodes, and we're making sure that they all communicate with each other.
Ah,
So,
okay.
that's it. Yeah, with Falcon, it's the entire model is running on one node, but you can have multiple. You'd have the entire model running on multiple nodes. You see what I'm saying? So
Right.
you have
Right.
node running the
Yeah.
model, another node running the
And
model.
and and these are just like little nuances of the
Yeah.
models that you're gonna to have some sort of like domain knowledge around, right?
Yeah, I
Um,
recommend people play around,
mhm,
with it, and then they see.
mhm.
But it really it depends on what the model supports that you're using. Right? If it
Got
supports
it.
sharding across nodes, then
Mhm.
we can enable that. Um,
Yeah.
yeah,
Um, as a user, this is just me being lazy again.
yeah,
Um, as a user, I appreciate the presets,
yeah,
um, which I don't think we really touched on. Maybe we can head over into the repo and just really talk about the presets here. But I mean, the stuff that you talked about, like sharded models and being able to distribute that across, that's like a lot of stuff that you'd have to think about
you
like
don't got to
up
worry about
front.
it, Paul. Yeah, that's what.
And
Yeah.
so Kaito takes care of all that, and that's kind of like
Mm.
why these presets kind of exist, right?
Yeah, we really
Um,
wanted to make it a lot simpler for people.
mhm,
Yeah, to
yeah.
be able to deploy.
So what do we have in terms of like the models that Kaito supports right now? That's like in the repo somewhere. I saw it.
Yeah, yeah. So we have is there I believe there's a supported models.yaml file in here.
I did see that. I did see that.
Yeah.
Bum, 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 bum. Ah, right here. Detailed usage of supported models can be found here.
Yes. There we go.
Cool. So model family. So Falcon, Llama 2, and Llama 2 chat for now.
Yeah, yeah, and I can share this too. This is like on our open source roadmap and
Mhm.
everything, but Phi 2 and Mistral are going to be included in the next release.
Interesting.
Yeah.
Okay. Okay.
Um,
So, okay. So here are the specific models. So, Falcon 7B instruct, which is what I used, and then Falcon 7B, right? What's the
yeah.
difference?
Yeah, so Falcon 7B instruct is fine-tuned for chat
Mm.
application.
Hmm.
So we yeah, I recommend. Well, it depends on the use case, but I think most people would want to use the instruct model.
Hmm.
Falcon 7B, that's something where so I've actually there we've addressed this in our repo itself, but we're working on fine tuning. And
Mm.
so having Falcon 7B there, that's something we've also included because we'll have, the ability to then have people add their fine tuned weights, to that.
Yeah.
Yeah. Yeah, and they're coming from Hugging Face. These are all open source, Apache 2.0. So we're able to
Yeah, look
use
at
it.
that. So Falcon 7B, they said, is a raw pre-trained and should further be fine-tuned.
Yeah.
I gotcha. And then it says, hey, we recommend you taking a look at Falcon 7B instruct. Okay,
Right.
that's really good to know. And did you mention fine-tuning is coming to Kaito as well, or?
Yeah, that's something we're working on. Might have noticed that it opened some open PR on that. So yeah,
I was snooping around,
you're
Ishan. I was
snooping
snooping around in the PRs.
Yeah,
And I did see fine-tuning API.
nice.
Okay.
Yeah.
That's cool. That's super cool.
Yeah.
Yeah. So I mean, pre-trained models then essentially is you and your team doing all that research, figuring out what's the best, I guess, configuration, and then packaging all that into a container, right? And then you host it. You host a container model, or
are you talking about training right now, or you're mentioning?
No, just the presets in general.
Oh yeah. So exactly. We're making sure that you have the necessary resources to run that model, so that the necessary GPU memory and hard disk space. And we're making sure all the relevant dependencies are installed, right, for that to run that model. And there's certain nuances with certain models, right? There's different parameters some models might take. Some models have weights in floating point 16. Other models have it's called bfloat 16, which is another type of precision. So we make sure that, and then we also have to make sure then your hardware supports that precision, parameter. So we make sure that we're running the appropriate parameters, for that model. We're taking care of all that. And I can even get into then there's three types of preset. There's three types of workspaces you can create, right? Just going off the preset conversation. You have like the Falcon we have, which is a completely public open source model, which the model weights are included, everything is included in the image for you. You then have the private presets like Llama, in which case Llama has Llama has an additional license you have to agree to. So you have to build that image yourself. And once you do that, then we're able to we actually have the Docker file that you need to build. We have all the instructions actually, right there in the repo for how to build that image, and then we're able to take it from your private ACR that you pushed, and then from there we
and this is because, like, if I'm not mistaken, the licensing model for Llama 2 is, I guess, interesting.
Yeah,
it is open source, but it's not open source for like commercial use. Is that the case? Why we can't host it?
I have to check in, but I forget what specific license it was, but yeah, you have to like agree. You have to sign up on their thing, and you just have to hit that you agree, and then it'll send you like an email with the model.
Yeah. Okay. So this is why, as a user, if you want to use Llama 2, then you just have to go and build a Docker container yourself, as opposed to
exactly. And we give super simple instructions. Like this file right here, it's really simple. We give you the Docker file that you need to build it. You just have to push it to your private ACR because we can't publicly host that, right?
Got it. Yeah. Okay. I mean, that makes sense.
Yeah. So, and then you have I'll just wrap this up then. So you have the private presets, the public presets, and then there's a third one, which is just, you can provide a custom pod template. So you could just, in that case, we're just provisioning the GPUs for you, installing all the dependencies on the GPUs. You just, you can just put in whatever image you want to run, basically, in this custom pod template.
Got it.
Yeah.
So you can truly bring your own model.
Yeah.
And just leverage Kaito to provision the GPU for you. You're still you're still using a workspace CR though, right?
Yeah, exactly.
Gotcha.
Yeah.
Gotcha.
So both for the private presets and the custom resource, you have to provide an image URL, like a ACR URL, or wherever you're getting your image from.
Mm-hmm.
So but with the public one, you don't. So with Falcon,
Got
for
it.
example, you didn't have to provide that. It's just coming from MCR. Yeah.
Yeah. But the presets is coming from your team, testing, and it's basically good to go, right?
Yeah.
Okay. Cool. Let's see. I think there's a question that popped up here. Can we install Kaito operator on a different platform other than AKS?
So yeah, so we are using Carpenter. This is something, we're investigating. Yeah, running it on more
other
platforms.
cloud platforms. Yeah. Because my thought was that this is AKS specific for now.
So as of right now, it's only works on for AKS currently. But we're investigating that because Carpenter can integrate with other cloud providers too.
Oh yeah. That's why it was open source and accepted by the CNCF. So yeah. Okay. I mean, that's one of the reasons why I was it was kind of cool to see the Carpenter, at least the APIs are in there, right? So it's just a matter of, who's going to implement that API, is it going to be node auto provision, whatever. So cool. Let's see if we can wrap up this deployment here, because what did we do? We actually took away the Azure OpenAI. Let's see how that. Okay, it only took 1 minute. Cool. So now if I jump back over to my resource group, you will see, there we go. OpenAI is gone. Okay. So now, because I want to swap the underlying, I guess, model, right? I'm going to have to redeploy some of these Kubernetes resources by scratch. These are things that were taken care of for me by my Helm chart installation that AZD actually deployed. But here I'm just going to deploy these things manually. And I think this will be good to see as well. So basically, what I'm going to do is I'm going to create a new config map. And within that config map, I'm going to specify, because I have a switch in the AI service, that Python based AI service that I talked to you about. There's an environment variable in there, and I can either switch it to use local LLM or not. And so I'll set that to true, and then I will pass in the URL of the service that's running inside my cluster, right? So this is essentially the that was a terrible box, but you can't even see the text anymore. But that is essentially the name of the workspace, and then this is the inferencing endpoint, right? So which is /chat. Okay, so there's my config map. I'm going to redeploy the AI service. And I'm going to basically, I mean, this is pretty standard stuff. So I'm just going to point it to the config map. And there's nothing else very special there. It was really the config map that's special. So let's go ahead and redeploy. So bounce out of there. Boom. So you'll see I have a new config map created, a new AI service created, and a new deployment and a service created. So, and if you're curious to see where that environment variable is used in the source code, in the repo, you can actually dig into the SRC directory. There's an AI service, and then I believe it's under routers, and the description generator. And you can see here, so this description method, there's actually some logic in here. So if I want to use local LLM, then I'm just making a raw HTTP call to the inferencing endpoint. If I'm not using local LLM, that's when it's going through the semantic kernel SDK and going through that route to talk to OpenAI. Because number one, I haven't caught up on semantic kernel in a while. I'm not even sure if it supports some of these models. I know OpenAI for sure, but with some of these other inferencing services, might not be supported on semantic kernel. So I'm just calling a raw HTTP call, and basically making a post request, and I'm setting it this payload. So I'm setting the prompt temperature and top P. And that brings me to a point. That stuff is actually documented in the repo. Can't remember where. Let me see. Is it under inference?
Oh, are you talking about the curl request format?
Oh, I'm here. It's like right in front of me. Example with configurable parameters. Duh. So yeah, prompt, right? And then all these different parameters that you can send into your inferencing endpoint, right? So it's all documented here. So thank you for putting that in there. So this is awesome.
Yeah. Obviously, you don't need to set every single one of them. Where you just
right. So that's why I only set the two that I really care about, which is temperature and top P. I mean, we can further refine it, but for right now, I think it's good. And let's just see how good it is. So I know I deployed. Let's see.
I think the main thing people might change is that max length to get longer responses.
To get more concise responses, like shorter responses?
So max length includes your input question as well as the output together. So if somebody wants more either context or more output, they would increase that.
Yeah. That might be helpful in the other Falcon 7B model, the non-instruct. I was playing with that a couple of days ago, and man, that thing could ramble on.
Yeah.
So, okay. That's a good tip there, Ishan. Thank you. Let's see. How is my deployment? Get PO pets. All right. It should be working. So let's go ahead and test it out. So if I just go back here and add a new product. Okay, Bear Snack is there. That's better Bear Snacks. Okay, because this is our second iteration of Bear Snacks. And let's increase the price a little bit. So sorry, Steve, it's going to be more expensive for you. Dog name Bear, treat, yummy. How about those keywords? And I will ask the AI assistant, which is now calling the Falcon 7B instruct model. Hey, look at this. Boom, 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 boom. It's a little more wordy, but I think it's okay. Better Bear Snacks are perfect to reward your furry friend. Okay, I like that.
Yeah, I've noticed Falcon can be a bit funny too. Like it has a sense of humor.
Yeah. I like that.
Yeah.
Your furry friend can enjoy a tasty treat without any guilt.
Yeah.
I don't think dogs feel guilt.
I don't know how it comes up with this. Yeah.
Oh, yeah. That's pretty cool. Okay. So there we have it. We basically deployed our sample store application. We initially started off with the OpenAI model, and then using Kaito, we were able to deploy the operator, and all we needed to do is deploy a workspace into the cluster using a preset configuration, and then boom, just swap out the underlying model in our application, and we're off. So that was pretty fun for me at least.
Yeah.
Let's see. Am I missing anything else in this workshop that I should make you aware about? I don't think so. I think we're good. Oh, the other thing. Cleanup, that's super important. You don't want
Right.
to keep this thing up and running, especially in a demo environment, right? So just make sure when you are done, just run the azd down force command, and it'll actually delete all of your Azure resources for you. So
Yeah.
um, cool.
There was one question actually we didn't get to. So somebody
Mhm.
asked here if your count is equal to 1, then how many inference requests can be served at the same time? Yeah. So answer to that is we serve one inference request at a time. If you submit additional ones, they will get queued up to get answered. And the reason for that is you can only use the hardware, the GPUs will only do one forward pass at a time. So we're bottlenecked there. So yeah. So that answers that.
Cool. Thank you. Yeah, so just to quickly summarize, I think we'll be able to get out of here a little bit early today, but basically, hopefully you have a pretty good idea on what Kaito is, the Kubernetes AI Toolchain Operator, some of the problems that it aims to solve. And for me, number one is your time to inference. Based on open source models, right, inside of your AKS cluster. And so we were able to just see it all in action, see how we go about deploying it, see how long it takes to provision. It actually surprised me. 10, 11 minutes is pretty good. So, and then we're able to actually integrate that into our sample application. So that was pretty cool. In terms of next steps, what do we have here? So next steps, I would say many of you probably weren't able to do the workshop due to maybe quota restraints on the virtual machine. So once you do get access to that quota, I would say do the workshop and visit the Kaito GitHub repo, right? And you want to just quickly talk about suggesting new models, Ishan?
Yeah. So first I want to say like Kaito is really growing, and this is just the beginning. There's so many, exciting projects on the horizon. One of them I could talk about, for example, fine tuning. That'll be having a fine tuning API on Kubernetes is like, that'll be super, helpful for people. And so I think that there's, and so going back now, we want people to be suggesting new models to add to Kaito. And we have all these really interesting foundational models right now, right? Like just in the ecosystem, Llama, Falcon, Mistral, Phi. And so so and that's really compelling and good for the ecosystem. And so that's why we want people to contribute. There's a guide here on how to contribute, and this is the guide here on how to make a proposal to add an additional model to Kaito. So
Right.
yeah, we really encourage people to do that. Yeah.
Cool. Yeah. I mean, again, huge benefit for me in using a preset, and having more presets, I think, in this repo will be like super cool. Unless you like rolling your own pod templates. I mean, that's totally up to you. You can do that. I personally don't want to do that.
Yeah.
Onboarding new OSS models. This is great. So folks can actually create a PR and basically follow a specific template to do that. So that's pretty cool. Cool.
Right.
And I would just highly encourage you all to just explore the repo. If you have any questions regarding, is this probably the best place to get in touch with you?
Yeah,
Ishan?
we recommend raising an issue. Yeah,
Okay.
for sure.
Okay. Raising an issue. Cool. So if you have any questions, any feedback, please submit an issue. So, and pull requests are always welcome, right?
Yeah, of course. Yeah, open source. Yeah.
Cool. All right. So what do we have next? I would say, we're pretty much concluding episode number 2, but we do have 2 more episodes on the plate for you. Steve Morawski, who's been in the chats these past 2 weeks. He'll actually be coming online next week and the week after. Some pretty amazing content there around observability and global scale. So you wouldn't want to miss those episodes. So go ahead and scan that QR code so you can register for the following episodes. And then last but not least, I would like to invite you all to please subscribe to the AKS community YouTube channel. This stream is actually live streamed there. The recording will be there as well, in addition to the Microsoft Reactor YouTube channel. So if you are getting started with Kubernetes, Azure Kubernetes service in general, head over to this channel. There's a lot of great content there, and you'll be able to find us there. So with that, I think we are at the end of our show. I do want to, thank you, Ishan, for coming out and sharing your knowledge around Kaito. So this has been...
Thanks for having me, Paul.
Yeah, this is super cool to see. So looking forward to maybe having you on again, when fine tuning comes around. So yeah. So for everybody else that's stuck with us, thank you, appreciate you, and I will see you on the next one. So see you all.